All right, let's kick off. So, good morning, everyone. So, today we are going to cover one of the most important topic of algebra, and it is called linear equations. I know you would have heard about it before, done that before, uh, but we are going to give it a different perspective today, right? I have seen even my grade 12s fumbling with this topic, which is quite late in the game. So I will give you some tips and tricks which you would have heard from your teachers or tutors in case you've got any before as well. I'll brush that up and I will also give you some ways to deal with linear equations, which I call my perspective, my way of solving the linear equations from my experience. So it's a mix of what's being taught in the school books. Some of it is my experience, right? So without any delay now, I've got 25 people, they're enough for us to kick off. I will share my whiteboard and then we'll go from there. I think there are 25 people and the rest will keep coming in. So I'll share my whiteboard now. So first things first, uh, what is an equation? I'll just reiterate, what is an equation? An equation is an algebraic entity which has two expressions sitting, on the left-hand side and the right-hand side of an equal to sign. So when I say two expressions, so if I write x plus 5 equals to 7. Now this is an equation. You have x plus 5 sitting on the left of the equality sign, and you have 7 sitting on the right-hand side. Now, I'm not asking you to solve it, so don't jump the gun. Just hear me out, okay? Don't solve it. You no need to solve, right? Till the time I ask you, right? All right. Now, so this is an equation. Now, equation always has two sides. The left-hand side is called the LHS, and the right-hand side is called RHS. And there's an equality sign that always tells us that we need to maintain the balance between the left hand side and the right hand side. At any given point in time, we cannot break this balance in order to maintain the sanctity of this equation. Now, real life in real life equations, or most of the time linear equations, are very commonly used without we being really, aware of it. So for example, if I go out to a shopping center and I want to buy a pair of jeans, and let's say the pair of jeans costs $50 and I need two jeans, then I'm giving them $100. In the hindsight, in this calculation, what I've done is I have solved a linear equation. So rather than getting two jeans, if I don't know how many jeans I need to buy, then I replace this 2 with an unknown x. So the cost that I'm going to pay for the jeans is 50 times x. And that is a linear equation. right? People are still joining in. So this is a very classic and a very basic example of linear equation. It has an equal to sign. It's got the cost on the left-hand side, and it's got 50 times x on the right-hand side. So this is a very classic example of a linear equation. Now, as we did in the very first lesson a few, I should say, months back now, what do you mean by linear equations? Linear means one. Linear means one. But what is one? One is the power of x, power of the unknown variable. In this scenario, I call it as x. So if I take this example here of x plus 5 equals to 7, my x has a power of 1. X has a power of 1. So all the equations which have a power of 1 are linear equations. So that's number one. Very, very important. Now, with that in mind, that linear equations is, a game that we play every day in our daily lives, let's try to understand how do we solve this linear equation, right? So I'm going to the next page now. So keep moving along with me. I'm on whiteboard page number 2 now. All right. So now, this topic is very, very serious topic, right? And from today onwards, I will not tolerate, and I'm again reiterating this, I am not going to tolerate anyone who is going to disturb and distract the whole group and me on the chat. The chat is right in front of my eyes. It is distracting me when you start typing anything which is not required. So the moment I see anyone disturbing the whole group without notice, that person will be pushed out into the waiting room. Okay, so just be mindful of that. All right, let's move on. Now, there are some rules of linear equations. I'm at page number 2. The rules are that we need to be aware of opposite operations first. When I say opposite operations, that means a plus or an addition has the opposite of subtraction. Similarly, a subtraction has an opposite of addition. I call it as opposite or inverse operations. Inverse operations. Then your multiply or a product has an inverse, which is division. And your division has an inverse of multiplication. So addition, add, and it's a two-way arrow, is a subtract, and a multiply has division. Remember that. Very, very, very important. Let's use these inverse operations to solve a very basic linear equation. So the equation that I gave you at the start was, and I'm not telling you to solve right now, I'm just requesting you to listen to what I'm saying. Let's say I have a very basic equation, x plus 5 equals to 7. Now, in order to solve x, the goal is leave me alone. But hang on, who's saying this leave me alone? The variable x is telling everyone in this equation to leave it alone. That means if somehow we leave this x alone on the left-hand side, on the either side primarily, either left-hand side or right-hand side, if the x is left all alone and everything else is being taken to the other side of the equation, of the equal to sign, we solve x. Now, in this particular scenario, if you look at it, x has this positive 5 sitting, this positive 5 sitting with itself. So we need to leave x all alone. So x is saying, leave me alone on the left-hand side. So what is sitting with x? A positive 5. And now what is the inverse of positive? A negative. So what I need to now do is, I'm writing this again. Put a bracket and say, and take away minus 5. Say minus 5 here, minus 5 here. Always put a bracket. Once you have the bracket in front, now the next step is open the brackets. So you will have x plus 5, x and a minus 5 equals to 7 minus 5. Now what's happening on the left hand side? 5 and 5 cancels, and x is left all alone. And what's happening on the right hand side? 7 minus 5 is 2. So finally, x is equals to 2. We were able to leave x all alone on the left hand side, and we call it as leave me alone strategy, which means I am leaving the variable all alone in order to solve its value. Let's go to the next page and probably do one more inverse operation. I'm on page 3 now. I haven't asked anyone to solve yet, so keep the chat silent. All right, let us do exactly the opposite of it, what we've just dealt with. So now if I have x minus 5 equals to 7, now I have a negative 5 sitting with the x here. So somehow if I get rid of this negative 5, x will be left all alone on the left hand side. So mind you, again, this is left hand side, this is right hand side. X has a negative 5 sitting with it. So the inverse or the opposite of negative is positive, or subtraction is addition. So what I'm going to do is I will put the bracket and I will add 5 on both the sides. And now, when I open the bracket up, I have x minus 5 plus 5 equals to 12. And now 5 and 5 is cancelled, x is 12. So x is now left all alone on the left hand side, and we found the value of x, which is 12. Can I ask you now to solve this equation? X minus 5 equals to negative 7. Go for it. Good. So what we've done here is that we had a negative operation. I will say x minus 5 plus 5 in a bracket equals to negative 7 plus 5. Open the brackets. See, I know most of you are not used to putting a bracket, but I will tell you the reason why we are doing it. Right. So 5 and 5 is cancelled, so your left is x equals to negative 2. All right. Cool. Good job. Let's go to the next page. And now we are going to do multiplication and division. Let's say I have 5x equals to 20. I mean, these are very basic linear equations. I know you can do it, but I'm just teaching you the technique, right? I have 5x actually means 5 times x, so it's a product. So multiplication has an inverse operation of division. So I will say 5x divided by 5 on both the sides. But a quick question, why are we doing it on both the sides? I told you at the start, we need to maintain the balance. Maintain the balance of between left hand side and right hand side. So that's the reason that whatever is happening on the left hand side has to happen on the right hand side as well. Now 5x over 5, 5 is gone. So left at x equals to, now 20 divided by 5 is 4. So x is equal to 4. Good job. Now x over 5 equals to 20. Can you do this? I will do that, Shaban, don't worry. I'll keep explaining this. Right. Okay. Now, we have x being divided by 5 here. The division has its inverse operation as multiply. Always put the bracket, please. Always put the bracket on both the sides. This is hygiene. If you don't put the bracket, the chances of going wrong are quite high when you are dealing with complex expressions. Now, Open the brackets up. 5 times x over 5 equals to 20 times 5. 5 and 5 is cancelled, and what I'm left is x equals to 100. I'm moving to the next page now, page number 5. All right, if I write 5 over x equals to 20, what will be the value of x? Can someone tell me? It's a trick question. I'm looking at the answers. There's nothing called maybe here, Eklavya. The maths doesn't have a maybe. All right, okay. Unfortunately, all of you are incorrect. So hold your horses, right? Hold your horses. All of you are right. I think AV is right. So almost all of you, 99% incorrect. Now, that was a trick question, right? I will deal with this later. The answer to this question is x is 1 over 4, not 4. Okay, now let's do it basically. Why should we, push it through? Now, let's say how you get 1 over 4. See, if you concentrate on what I'm teaching rather than chatting, you will be better off, okay? All right, so if you've got this kind of a scenario where you have two fractions, you have a fraction 5 over x equated to another fraction 20. Now 20 is a fraction. I can write 20 as 20 over 1. So when you've got this kind of a scenario, when you've got two fractions being equated together, cross multiply. 20 times x makes it as 20x equals to 5 times 1 makes it a 5. So your linear equation now looks quite easy. So you have 20x equals to 5. So that is the trick that no one teaches you in schools. So now you can do easy. Now what is x now? You've got 20 being multiplied by x. So what is the operation of reverse operation of multiply? That's division. So I'll say 20x and I'll say brackets being divided. I'll say 1 over 20. So 20 is gone. And what you're left is x equals to 5 over 20. And the simplified version is 1 over 4. 99% don't know this. All right. That's the trick from my hat. And that's what you're here for, right? So silently and patiently just hear me out, okay? All right, let's move to the very basic stuff back again. Let's try to sort of mix it up now. Let's try to mix the operations up. And this is where it becomes funny. All right. Now, let us say you've got, let me just pull out something interesting. All right, let's do this. 2x take away 6 equals to 10. If I may ask, can you please solve this and give me the value of x? And then I will explain a few ways to do it. x is 8. Let's understand how we get x equals to 8 for students who have not been able to do it. My leave me alone strategy, my leave me alone tells me that x has this 2, a positive 2, and a negative 6 sitting with it. The positive 2 is a multiplication to x, and a 6 is a subtraction to x. Now, I need to get rid of these two numbers in order to leave x all alone on the left-hand side, and hence solve its value. Which number should I get rid of the 2 first? Can you tell me? Which number should I get rid of first? Okay, there are mixed answers here. So let's divide this into two parts. I write this as 2x minus 6 equals to 10. Let's get rid of 6 first. This 6 is a subtraction, so the opposite sign of subtraction is addition. I'll put this in the bracket and I'll say plus 6 equals to 10 plus 6. I open the brackets up and it becomes, on the left hand side is 2x minus 6 plus 6. On the right hand side it is 10 plus 6 is 16. So eventually 6 and 6 is gone. So your remaining is 2x equals to 16. Now in order to get rid of this 2, which is multiplying x, I need to divide it by 2 on both the sides. So 2 is cancelled. X is 16 over 2, which is 8. So x is 8. Now let's look at this question and try to get rid of the 2 and see how we can do it. 2x minus 6 is 10. Now, listen to me loud and clear without any distractions. I need to get rid of this 2. 2 is being multiplied. So the reverse operation is a division. Let's divide everything on the left-hand side and right-hand side with 2. So I will say a division is 1 over, and I'll put the bracket 2x minus 6 equals to 10 divided by 2. That's the first step. I'm getting rid of the 2 now. Open the brackets up. This is very important. I tell you, not many know what I'm solving here. Not many know. Everyone, 99.99% will get rid of the 6 first to get to the answer, which is fine. But they don't know. In fact, most of you would not know how do you get rid of 2 first. When you are opening the brackets up, you see what's happening. This half, hear me out, this half is going to get multiplied to every term inside the bracket, the distributive law. Let's do it. 2x over 2, take away 6 over 2 equals to 10 over 2. A distributive law. Let's see what's happening now. I'll change the color. 2 is cancelled. 2 times 1, 2 times 3. I'm simplifying the fractions, and 2 times 1 and 2 times 5. Let's see how your equation now looks like. So first term is now reduced to x, take away 3 equals to 5. Now it's easy. Just get rid of this 3. X minus 3, add 3 on both the sides. Get rid of 3 when you open the bracket up, and your x is 8. You see how I can get rid of any number that I want to. The rule is that you need to put the brackets out and then do the operation, use the distributive law to solve it. All right, let's do one more. I'm going to the next page now. Three y plus 1 over 2, that's all over 2, equals to 12. Go for it. Let's see what you do now. All right, let's see how we arrive at 7. There are again multiple ways of doing it. So what's the first number you want to get rid of here? What's the first number you want to get rid of here? I mean, I can get rid of any number, honestly speaking, but 2 is the easiest one to get rid of. So let's get rid of the 2 first. Now 2 is dividing the whole expression on the left-hand side. So I need to multiply 2 on both the sides. So I can say 2, and within my whole bracket, I can say 3, and I put another bracket in. I will just write it as is. Now, 2 and 2 will cancel, and you have 3 y plus 1 equals to 24. Now, there are 2 ways of solving from here. I can open the brackets up on the left-hand side, and that will be 3y plus 3. So 3 gets multiplied using distributive law equals to 24. Now I can get rid of this positive 3 by taking out, by doing a subtraction on both the sides. So this becomes 3y, 3 cancels, and 24 take away 3 is 21. And y is then divided by 3 on both the sides. So you get y equals to 7 times. Y equals to 7. Another approach could be if I don't open the brackets up and I say, let's get rid of, so I've got this expression here on the left. Yes, Dash, we can cross multiply. But here what I'm saying right now, concentrate here, all right? I can get rid of this 3, which is multiplying by dividing on both the sides. So now this 3 cancels, and this becomes, the expression becomes, on the left hand side becomes y plus 1 equals to, on the right hand side, it is 8. And then I say y plus 1, a positive 1, I have to take negative 1 on both the sides, and 1 cancels, y equals to 7. So you have 2 ways of solving the same equation. There's another way called cross multiplication. Let's quickly do that. See, the point is, whatever way feels easy for you, do that. I'm writing this again. So we had 3y plus 1 over 2 equals to 12. Now, this 12 can be written as 12 over 1. And I just told you that when you have 2 fractions on both the sides of an equality sign, you can cross multiply. So 3y plus 1 is being multiplied by 1. All of that is being multiplied by 1 equals to 12 times 2. I'm just cross multiplying. That's about it. So this is 1. 1 times 3 is 1. And 12 times 2 is 24. And now you can use the 2 ways that I explained you by opening the brackets up and solving, or take this 3, get rid of this 3 first, and solve it. All right, cool. Thank you very much. Let's move on. All right. Let's do one more variety. X over 3 plus 1 equals to 7. Probably I'll take the next page. Let's go to the next page. Right down here. X over 3 plus 1 equals to 7. Can you solve this? Leaving x all alone simply means solving for x. That's about it. There's nothing new in it. I've just put some fancy words around it. That's it. So if you don't get it, forget it. All right, let's see. 18 is the answer. Good. Let's try to do it. Let's try to do it in 2 different ways. I'm just telling you how you can solve one single equation multiple ways. Let's try to get rid of the 1 first. So x over 3 plus 1, and I put it in the bracket and I say take away 1 on both the sides. So x over 3 plus 1, take away 1 equals to 7 minus 1 is 6. 1 gone, and you have x over 3 equals to 6. And now I'm going to multiply 3 on both the sides, and you have x equals to 18. All right, now the second way is, let's try to get rid of this 3 and see how it works. Now, this 3 is dividing the whole expression on the right hand side, on the left hand side. So let's multiply the whole expression on the left hand side and the right hand side. Now, open the bracket and apply the distributive law. So you have 3x over 3 plus 3, 1 times 3 is 3, equals to 21. 3 gone. X plus 3 is 21. And take away 3, x equals to 18. You see, it doesn't really matter how and what is being you're trying to get rid of. Let's do one more. Two x plus 5 equals to 18. Go for it. As I promised at the start, a few students have been put in the waiting room, and they'll not be allowed to in, at least for this session today. So please mind the chat. All right. 3 students pushed out, a few more to go if you're not behaving yourself. All right. Now, now I can get rid of the 2 first. Let's get rid of the 2. So this 2 is multiplying. I can divide on both the sides. So 2 gone. X plus 5 equals to 9. Now I've got this 5 here, and I can take away 5 on both the sides. So I open the bracket up. X is 4. Another way, let's do the distributive law and open the bracket up. Multiply 2x plus 10 equals to 18. Now you've got a choice. You can get rid of the 2, you can get rid of the 8, you can get rid of the 18, up to you. The easiest is to get rid of 10 first. So I'll say 2x plus 10 within the bracket take away 10 equals to 18 take away 10. So 2x, 10 gone when I open the brackets up, and this is 8. So x is 8 divided by 2, which is 4. That's the way you solve this. All right? Okay, Let's do one more. I hope this is making sense today. All right, let's do one more. 3m minus 4 plus 8 equals to 5. Go for it. Solve m. M is not 1, m is not minus 1, m is 3. Okay, let's solve it together. Let's solve it together. First of all, okay, hold on. Stop solving. Let's try to do it together. Don't worry, it's okay. All of you tell me first, which number on the left-hand side would you try to get rid of first? All right, some of you have said 8, some of you have said 4, a few of you have said 3. The easiest is to get rid of 8. In fact, I can get rid of anything, right? Let's try a few approaches here and see what fits you in, what fits you better. Let's try to get rid of the 3 first. Let's see what happens. I have this expression, and that is where linear equations are tricky, I tell you. I'm rewriting the expression. This 3 is multiplying. It's a multiply operation. I have to divide it. I have to divide it. How do you do the divisions? You say, you write this full expression again, and I divide it. All of that. I can write it like this on both the sides. And then, or probably even easier, would have been to divide it like this. Put a bracket. See, when you're getting rid of this 3, it makes the expression quite cumbersome, right? But we'll do it together. Now open the brackets up and let's see what happens. I'm changing the color. Be with me. This is complex, all right? No one in school will teach you. This 1 on 3 gets multiplied here, and this 1 on 3 gets multiplied here. So 1 on 3 times 3 times m minus 4 plus 1 on 3 times 8 makes it a 5 on 3. Is the first step clear? The step in the purple that I've just done. I need a yes or no. We've got 6 more minutes. I have to finish this up, guys, quick. All right, next step. This 3 is gone. So what is left? For the first term, I have m minus 4 in the bracket, plus this becomes 8 on 3 equals to 5 on 3. Now you've got rid of 3. That's the way you get rid of 3. And some of you said you can get rid of 4. No, you cannot get rid of 4. Anything which is inside the bracket, that's another important rule. Anything within the linear equation that's inside the bracket, You can't get rid of it straight away. Don't do that crime. You can only get rid of the numbers easily which are sitting outside the brackets. I mean, I can still get rid of 4, but it takes a bit more sort of, challenge to get rid of 4. This 4 is not 4 actually. This is 12 because 3 is being multiplied. So this is 12. All right, let's continue where we left. Open this bracket up. M minus 4 plus 8 on 3 equals to 5 on 3. Now, I've got this expression, m minus 4 plus 8 on 3 equals to 5 on 3. Now, I can get rid of this 8 on 3 or a negative 4, whatever I can. So let's get rid of, up to you now. You want to get rid of 4 or 8 on 3 or both, your choice. Let's get rid of, let's say, 8 on 3. So I'll say m take away 4 plus 8 on 3, put a bracket, minus 8 on 3, minus 8 on 3. Is this step clear? Next, open the brackets up. Plus 8 on 3, negative 8 on 3 equals to, this involves a bit of a fraction. 5 on 3 take away 8 on 3 is negative 3 on 3. This is basic fractions. It is getting complicated, I know. Now, here I will slash 8 on 3 and 8 on 3. And this is negative 3 on 3. So my expression now is m take away 4 equals to negative 3 on 3. But hang on, what is negative 3 on 3? Is it not minus 1? 3 times 3 is 1. So now I have m minus 4 equals to negative 1. Yes or no? So now I say minus 4 plus 4 minus 1 plus 1. M equals to 3. So finally, M is 3. M was not 5. No one told me 3. Now, this was one way how I got rid of 3 first. And getting rid of 3 made this expression and this equation super complicated. And it involved fractions. So the easiest way would have been to get rid of this 8 first. And that would have, you could have got rid of all the fractions that we just played around. Shall we quickly see how we can do this, get rid of this 8 as the last sort of topic for the day. So I have 3m minus 4 plus 8 equals to 5. Let's get rid of this 8. I say negative 8, negative 8. So I have 3m minus 4 plus 8 minus 8, 5 minus 8. 8 gone. 3m minus 4 equals to negative 3. Then I can get rid of this 3 by dividing it on both the sides. It's a product, gone. M take away 4 equals to minus 1 and m equals to 3. You see, I took just 3 steps here, or 4, by taking 8 out first. Whereas, if you look at the previous one, I'm at page number 11 now. It took me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. I hope today's linear equation session was useful. Please practice more, and I will see you back next Sunday. All right. Enjoy the rest of your day. Thank you very much. See you later. Bye.